My name's Nick DiVincenzo, and I'm an application engineer with Siemens. Today we're going to talk about some new functionality in SimCenter Test Lab called process variables. The general idea behind these processing variables is we've introduced these features or these functionalities that allow you to define a variable in SimCenter Test Lab in the Process Designer, which allows us to control either method parameters or calculations that you'd like to perform from a single location in the software. An example of some of the things that we could do is we could create a variable to control the frequency resolution of different channels. We could create a variable to control the tracking parameters for color maps, the minimum RPM, the maximum RPM, and the increment. We can adjust filter cutoff frequencies, scale factors, and we can also use these variables in the calculate method. So if you wanted to perform some math on a channel using a variable, that is something that we are now able to do in Test Lab. The general way that this would work is in the process ribbon, there's this process variables button that will open this dialog box, this process variables dialog box, where we can define these variables. So in this example, we're setting a variable for the cutoff frequency of a filter and the frequency resolution for a PSD calculation. And then in these methods here, we're able to, rather than typing in a number, so rather than typing in, for example, 4 Hertz here, we choose our variable, or in this case for our VAR filter, this 500 Hertz cutoff frequency, we add in our variable. And where this might be very useful is if you think of the example of a frequency resolution, you might have 4 or 5 methods calculating things like PSDs or auto power spectra or spectrum maps. Let's say you want them all to be the same frequency resolution. Instead of needing to click on each method, go into that method and set the frequency resolution, we can define this resolution variable and then choose that variable to be the frequency resolution for each method. And then anytime you want to change the frequency resolution for all of those methods, you can do it from one central location. In addition to these variables, we can also do some things that are slightly more complicated with these processing variables. We can create variables that change their value depending on the input data. What do I mean by that? I mean variables that change based on things like the name of the channel. So in an example I'll show later, we can use variables to scale different channels by different amounts. And we can also create variables that have different values based on the run name. This really gives us a lot of flexibility to do all sorts of calculations or processing within Test Lab using these different variables. I'll just jump right into SimCenter Test Lab. So in this first example I'm going to show you, I want to show you how we can set the tracking parameters of a couple of different types of map functions that we have in Test Lab to the same values using some process variables. The first thing I'll note, in order to utilize these variables, this expert mode checkbox needs to be checked on. It's available in the processing ribbon section of Test Lab Neo. This processing ribbon will be available if you're within the processing tab. I've got variables enabled. I'll come over here and I'll click on this process variables button. And I've got 3 variables defined. I've got lower RPM, upper RPM, and increment. I've set a lower RPM of 1500, an upper RPM of 3000, and an increment of 10 RPM. Now, if I was doing this from scratch, I would take some data and I would place it in the input basket. So let me find a run up. I'll place it in the input basket. I'll drag a spectrum map into the process designer and connect it to my input. And then I'll go ahead, I'll choose the way I want this to be tracked. So I want it to be tracked on my tacho channel. So I'll go ahead and select my engine tacho. I'll choose immediate up for the slope method. And now on these minimum, maximum, and increment parameters, on the right-hand side of the application, if I hover over that property, I see this little box with the X in parentheses in it. I can click on that, and then this dialog box turns into a drop-down where I can select from my available variables. For my minimum RPM, I'll choose the lower RPM variable. For the maximum, I'll choose upper RPM, and for increment, I'll choose my increment variable. I can hit close, and now for this map, whenever I want to change these tracking parameters, rather than coming in and doing it on the spectrum map itself, I can just modify the process variables that I've defined. And where this will be really nice is I've got these 4 different maps, and I have them all set to these variables for the RPM tracking settings. So minimum, maximum, increment, minimum, lower, minimum, maximum increment here. Same thing on my tonality map, and same thing on my prominence ratio map. If I wasn't using this variable concept and I wanted all of the tracking parameters here to be the same, I would need to change each of them individually if I ever wanted to change the parameters here. But now, whenever I run my data through these methods, it will utilize those tracking parameters that I've defined in the process variable section here. So if I look at my results here, my octave map is going from 1500 to roughly 3000 RPM. So it's utilizing those variables that I have set, likewise on my spectrum map. And if for any reason I wanted to change those parameters, I could just come in here and I could say, we'll do something more narrow range. We'll do 2000 to 3000, and I'll do a 5 RPM increment. So now instead of having to click on each of these methods and modify those tracking parameters manually, I've done that all in one central location. And when I run this process, I'll see for all of my map functions, those tracking parameters have now been updated. So it's a nice, convenient central location to be able to update these parameters. The next thing I'll do is I'll show an example of performing some calculations using variables inside the calculate method. So I'm going to start off here. Oops, let's delete these. We'll start off here saying I want to scale all of the channels in my data set by a scale factor. I'll just choose an arbitrary scale factor of 10 here. So that's my objective. Got a data set with a couple of channels in it. I'll replace that in my input basket. And in my process here, I've got my input block. I've got this define value block, and inside this define value block, I've selected my variable scale factor. And then I'm feeding that scale factor variable and my input data into this calculate method. Inside this calculate method, I've got some formulas defined. I'm going to take my scale factor variable, that's this first row here, and multiply it by all of my time channels. That is this row here. So I've got this formula R2, which is all of the time histories in my time file multiplied by my scale factor. I'll hit OK and close. And now I will run this process. And I should have another set of time histories. The original one is shown in green here, and then I have the time history that's scaled by a factor of 10 in red. So it took that process variable, that scale factor, and it used that in my calculation in the calculate method. What's kind of neat here is, to start, what I've done is all of the channels in this data set are multiplied by the same scale factor. But I have a little more control over that if I'd like. So I can add in another couple of lines in here. And then I'll choose a couple of other scale factors as well. So I'll do 2, and then maybe we'll do 1/2. So now that I've added in these variables, I'm going to go ahead and I'm going to choose which channel I want to have multiplied by which scale factor. So I'll do the Y channel scaled by 10, the Z channel scaled by 2, and the X channel scaled by 1/2. I'll hit OK here, and I'll hit run. And now if I look at my channel in the Y direction, that one should still be scaled by a factor of 10. If I look at my Z direction here, I believe that one was scaled by a factor of 2. And if I look at my X channel, this one should be scaled by a factor of 1/2. So let's move this down, and you'll see this is indeed half the value of my original channel. So these conditional variables, these variables based on things like the channel name or the run name, give you a lot of flexibility in finding these different parameters that you might want to use in calculations in your TestLab Neo processes. I've got another example here. So let me load this section. And in this example, I'm going to show, I think, another really nice feature in these process variables. I am able to load these variables directly from an Excel sheet. In this example, I thought it would be kind of cool to show adding some metadata to this data set. Within TestLab, we have a number of different properties that can be used for adding annotation to a data set. Would like properties. Within TestLab, we have a number of these user channel ID properties. Let's see if I can find it here. There we go. So we've got, in this case, user channel ID 1. And I can use this to annotate my data in any kind of which way I'd like. In this TestLab process here, what I'm going to be doing is I'm going to define some variables in an Excel sheet that I'd like to add to these different runs of data. And then I'll use this metadata editing method to add that variable to the user channel ID field. So in this case, I've defined a variable called driver, and that variable will be different based on the run of data. In this case, I've got run 1, run 2, and run 3. I'm going to add these all to the input basket. And then in Excel, I have a very simple little table here created where I've got the name of my variable, the value for that variable, and then the run name that I'd like each of these variables to be associated with. So in TestLab, I could either manually enter in that table, or I could import this information from Excel. So I'm going to import this directly from that Excel file. You can see that these variables get imported into the application. I'll select OK. And then I'm going to go ahead and I'm going to run my process here. And I should see in my picture here, I've got in the legend the user channel ID 1 showing. And for run 1, that user channel ID now shows Nick. For run 2, that user channel ID shows Steph. And for run 3, that user channel ID shows Pete. So I'm using these Excel-based variables to basically read that information into the user channel ID for each of these runs. Some other nice things about using the Excel import here is, if desired, let me maybe make a change here. Instead of Pete being one of our drivers, it can be Larry. I save this Excel file. If I come into Test Lab and I look at my process variables, I can keep that Excel file open and just update the results, and I'll see that variable immediately change. So I'm immediately rereading that variable. And there's also a nice functionality where when I'm importing this data from Excel, I can choose to have it automatically update the file before it runs the process. So if I make any changes to those variables, Test Lab will first look at the Excel file, it will update the variables in the process, and then it will rerun the process with the new variables. Let's give this a try. We can do something like Mo, Larry, and Curly here. I'll save this Excel file. And now, when I run this process, let me make sure I've got the right information in the input basket. I believe I do. Now these variables are reread upon running the process and appropriately displayed in the user channel ID. The final example here that I'll show with these user variables is a use case specifically designed for mission synthesis. We added mission synthesis into Test Lab Neo, I believe it was last year or last summer. And a very common question or request that we received is, for a lot of our mission use cases and repetition factors and so on, we often tabulate that all in Excel. And we would like to be able to use an Excel file to directly read that information in, rather than doing it in Excel and then having to redo everything inside of Test Lab. We are able to do that now in Mission Synthesis. If I show you quickly, I've got some repetitions defined in an Excel spreadsheet for a number of different missions that this electronic component had undergone. It was an electronic component in a vehicle, so there were some different road surfaces that it was being driven over. And I've entered in some arbitrary repetition factors for the number of times to repeat those runs in Mission Synthesis. If I look at this combine FDS and MRS method, I can choose how to define the lifetime. So I'm going to define it in repetitions. Something new that was also added is the ability to define the lifetime in lifetime percentage, which I think is also a very nice feature, but we'll keep it to repetitions for right now. I'll go over to this combination task here, and let's start by just using a manual input. The way that we had done this previously is there'd be some manual input that you would need to enter for all of these different runs for the number of repetitions that they'd undergo. Here we'll just do 100 for the rest of them for the sake of simplicity. But now, rather than requiring you to manually input these repetition factors, I can choose my Excel spreadsheet in my variable repetitions. And when I choose that, you can see it automatically updates these repeats with the information from my Excel file. They're no longer editable. I can't change them. These are automatically imported from my repetitions Excel spreadsheet. Now, if I wanted to make any changes in that sheet, I should be able to. Let's say I want this one to be 70 rather than 7. go ahead and resave this Excel file. And I should be able to come in here. I don't believe I have this to auto read, so I would come in and I would refresh. This now reads 70. I'll hit OK. And then it should display those correct repetition factors for me. So this off-road run is now set to 70. Just a nice and convenient way for the user who prefers to do a lot of their mission synthesis pre-work in Microsoft Excel to be able to bring that information over directly from Excel without needing to do all their work over again in SimCenter Test Lab. That was all I wanted to cover today in regards to this new process variables functionality that we've released in Test Lab 2506. Thank you, everyone.